Now we're going to hit the highlights of solving absolute value equations. Remember, anytime that we're solving equations, we're always asking the question of what will make the equation true. So we're going to start with this consideration. So let's consider the numbers -3 and +3 on the number line. So here's -3 and here's +3. And according to the definition of absolute value, and of course that definition of absolute value is how far a number is from 0 on the number line, what we've got here is 3 units to the left or 3 units to the right. So if the definition of the absolute value is distance from 0, then we can say that the absolute value of -3 is equal to that of the absolute value of 3. Why? Because they're both 3 units from 0. So always thinking how far from 0. It doesn't matter if it's to the left or to the right. So let's evaluate some absolute values here. Just a quick reminder that absolute value bars are grouping symbols, just like parentheses, just like brackets, just like braces, just like the big fat fraction bar. The absolute value bars are grouping symbols. So according to GEMS, order of operations, we need to do what's inside the absolute value bars first because they're a grouping symbol. So let's start with number 1 and just think of it as a question. How far is 10 from 0 on the number line? It's 10 units. How far is -12 from 0 on the number line? It's 12 units. Look at number 3. In number 3, this says 2 times the absolute value of 5. So we need to evaluate the absolute value first. The absolute value of 5 is 5, and then 2 times 5 is 10. Again, do what's inside the grouping symbol first. The absolute value of -10 is 10. Multiply that by -5. -5 times 10 is -50. Let's keep going. Do what's inside the grouping symbols first. 3 minus 7 is -4. The absolute value of -4 is 4. Bring everything else down. -3 plus 2 times 4. Follow order of operations. Grouping symbols, exponents, multiply or divide, then subtract or add. So we need to multiply first because of order of operations, and I'll move to the right. We end up with -3 plus 8, and -3 plus 8 is 5. Again, keep going inside the absolute value bars. So inside the absolute value bars, first we need to multiply. Then we're going to add. -15 plus 5 is -10. Then we are going to take the absolute value, which is 10. And we will multiply that by the 10 that's on the outside, 10 times 10, and get 100. Keep going. Remember, the absolute value bars are grouping symbols, so we need to work inside the absolute value bars first. So we've got -3 times -4 minus 4 times 5. So inside those absolute value bars, we've got a +12 and a -20. 12 minus 20 is -8, and the absolute value of -8 is 8. We will now multiply by -1/2, and -1/2 times 8 is -4. So those are quick evaluations. We're always following order of operations. That never ever goes away. It's always in effect. So here we go again. Solving absolute value equations. Remember our essential question. What will make the equation true? We're always asking that question. So let's consider this equation. The absolute value of some number is 3. So if we know that the absolute value is the distance from 0, we can think about this like we would on a number line, just like we just had. 1, 2, 3, -1, -2, -3. So we've got 2 answers here. There's 2 answers because there are 2 numbers, -3 and +3, that are 1, 2, 3 units from 0. 1, 2, 3 units from 0. So we're anticipating getting 2 answers on many of these problems. M is +3 or -3. That is our solution set. Let's look at the second equation. The absolute value of S plus 1 equals 5. So clearly S can be 4, right? Why? Because will 4 make this equation true? Yes, it will. But what's our other answer? Is it -4? Just like the first problem? Is -4 plus 1? -4 plus 1 is -3, and the absolute value of -3 we just saw is 3. So it's not that. Here's what we can do. We can take the expression that is inside of the absolute value bars, so S plus 1, and we're going to set it equal to +5 as a first case, and then we're going to set it equal to -5 as the second case. So we've isolated what's inside the absolute value bars, first set it equal to +5, also set it equal to -5. So we have a positive case to check, and we have a negative case to check. Remember, most of the time we're going to get 2 answers here. So -1, -1. I'm solving both of these equations. There's my 4. -1, -1, -5 and a -1 give us a -6, which, when we plug it in, will make the equation true. So if we have the absolute value of -6 plus 1, that is the absolute value of -5, and the absolute value of -5 is 5. So it checks. So here are our 2 answers, +4 and -6. Okay, we're going to break this down into steps on this problem, okay? So step 1, first step, every single time that we are solving an absolute value equation, our step 1 is going to be to isolate the absolute value. Isolate the absolute value. So basically, we want the absolute value bars to be all by themselves. In this equation, they already are. Fantastic. So after we do step 1, we're going to move to step 2. And in step 2, we are going to present both cases. We're going to write both cases. That is the positive case as well as the negative case. So here's how that's going to look. So 2x minus 3 equals 15, positive. This is the positive case. Remember, whatever's inside the absolute value bars, we're bringing it out. So 2x minus 3. Notice the 2x minus 3 does not change. It stays the same. But this is the positive case, and this is the negative case. So step 1, isolate the absolute value. Step 2, write both cases to consider. And then step 3 will be to solve both equations. Solve both equations. So here goes. Equation number 1, 2x minus 3 equals positive 15. Plus 3 plus 3. I'm just using the addition property of equality here. 2x equals 18. Now I'll use the division property of equality. Divide both sides by 2. X equals 9. There's our first answer. So, solving the equations. Plus 3 plus 3. 2x equals negative 15 plus 3 is negative 12. Divide by 2, divide by 2. X equals negative 6. Notice that I'm still doing everything I can, trying to keep my equal signs lined up. I'm working down the page. We always do that. Always do that when we're solving equations. So I have two answers here, positive 9, negative 6. Let's give them a quick check. 2 times 9. 2 times 9 minus 3. That is 18 minus 3, and that is 15, and the absolute value of 15 is 15, so the 9 checks. Let's plug in the negative 6. We're trying to be certain that negative 6 will make this equation a true statement. So, 2 times negative 6 minus 3. 2 times negative 6 is negative 12. Negative 12 minus 3 is negative 15. The absolute value of negative 15 is 15. It checks. There's our two answers. Step 1, step 2, step 3. Be certain that you're filling in your outline and your listening notebook with those 3 steps. We're about to use them again. So, first, isolate the absolute value. Isolate the absolute value. Now, in this particular problem that we're going to solve, the absolute value has 2, positive 2 added to it. So we need to subtract 2 from both sides. That leaves us with the absolute value of 3x minus 1 equals 0. So our second step is to find and set up our two cases, a positive and a negative. But we've really got to think about this, because my positive case, do I have a positive case? Is it possible to rewrite 0 as positive or negative? That's not going to happen because 0 is neither positive or negative. So this particular problem represents a very special case. Okay? Let's highlight the fact that we have a 0 here. So when we have a 0, there aren't going to be two cases. There's only going to be one case, one answer. That's it. So why? Because 0 is neither positive or negative. So one case, one answer. If 3x minus 1 equals 0, plus 1, 3x equals 1, divide by 3, x equals 1/3. Only one answer here. That's it. We can plug it back in and give it a quick check. Looking inside those absolute value bars, hopefully you're remembering that 3 is the same as 3 over 1. So if we have 3 over 1 times 1 over 3, they are reciprocals. We get 1 minus 1. And 1 minus 1 is 0. And the absolute value of 0 is 0. Why? Because 0 is 0 units from itself. And 2 plus 0 is indeed equal to 2. So our one answer checks. So very quickly, whenever we isolate our absolute value and it becomes set equal to 0, that is going to lead to one case with only one answer. So that's the time where we only get one answer. All right, next problem. First, isolate that absolute value. Isolate the absolute value. Remember, this is negative 4 times the absolute value of x plus 2. If there is no symbol in between the number and the absolute value bar, it is understood to be multiplication. So we need to undo multiply by negative 4. And the inverse operation of multiplying by -4 is dividing by -4. So -4 divided by -4 cancels, and we have done step 1, which is to isolate our absolute value. So step 2 is to set up your two cases. But once again, we need to take a closer look as to what is given here. We have an absolute value set equal to a negative number. Now, if you recall, absolute value, by definition, is a distance from 0. Is it possible for any number to be -6 units away from 0? No, this is not possible. It is never, ever, ever going to be true, no matter what we plug in there. So, all right, you're like, well, wait a minute, Hendry. Can't x be -8? Well, let's plug in -8 and let's see what happens. If we plug in -8, we get the absolute value of -8 plus 2. Does that equal 6? Well, if we follow order of operations, -8 plus 2 is -6, but the absolute value of -6 is 6. So, does -8 make it true? No. Ladies and gentlemen, nothing is ever going to make it true. So there's no need to even set up the two cases here, because when we have our absolute value isolated and set equal to a negative, we don't need to do any more work. We can immediately say that there is no solution. Because if our essential question asks, what will make this true? Nothing will make this true. There is no solution that will ever make this true. Okay, last problem. Here goes. Step 1, isolate the absolute value. There we go. So remember, we've got multiplication and we have subtraction. We need to go in reverse order of operations when we have multiplication and subtraction. So we are going to undo the 12 first. How do we undo a -12? We add 12 with the addition property of equality. So -12 plus 12 cancels. 18 plus 12 is 30. I'm going to line up my equal signs here. And I now need to use the inverse operation for multiplication, which is division. 3 divided by 3 is 1, so they cancel. So the absolute value of x minus 5 equals 10. So there's step 1. Sometimes it's going to take a couple of lines on your paper in order to isolate that absolute value. Second, we want to set up our two cases. We're going to have a positive case and we're going to have a negative case. So here's the positive. Remember, what's inside will not change. X minus 5 equals positive 10, or x minus 5 equals negative 10. So we're setting up our two cases. Remember, our two cases are one's going to be positive and one's going to be negative. And that's done. Third, we are going to solve for x. And we are going to get two answers here. Most of the time we will. So, plus 5, x equals 15, plus 5, x equals negative 5. So there's my two answers. Here's my solution set. X can be 15 or x can be negative 5. Both of these answers will make this equation true.